Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. In this video I will continue the explanation of the sets chapter. Equal sets. What do you mean by equal sets? Two sets are equal when they have the same elements. Every element in two sets A and B are equal if every element in A is an element in B and every element in B is an element of A. It means A subset B and B subset A, then they are equal. For example, A equal 172 and B 217. These two sets are equal because they have the same elements. For every x belongs to A, equivalent to say x belongs to B, it means x belongs to A, then x belongs to B, and if x in B, then x in A. It means that the two sets are equal. Remarks. What do you mean by x belongs to A union B? X belongs to A union B when x belongs to A or x belongs to B. If x belongs to A and x belongs to B, it means that x belongs to their intersection, to A inter B. X does not belong to A union B. What does it mean x does not belong to A union B? It means x does not belong to A and x does not belong to B. X is outside A and B. X belongs to A union B bar. If x belongs to A union B bar, then x does not belong to A union B. X does not belong to A union B, it means x doesn't belong to A and x does not belong to B. What does it mean? X belongs to A bar and x belongs to B bar, then x belongs to their intersection. To prove that A is subset B, we have to prove for every x belongs to A implies x belongs to B. One sense. If x belongs to A inter B, then x belongs to A and x belongs to B. X does not belong to A inter B. What does it mean? X does not belong to A or x does not belong to B. X belongs to A inter B bar. It means x does not belong to A inter B. X does not belong to A inter B means what? X does not belong to A or x does not belong to B. Equivalent, x belongs to A bar or x belongs to B bar. The equivalent to say x belongs to A bar union B bar. What do we conclude? We conclude that A inter B bar equals A bar union B bar. Similarly, we can prove that A union B bar equals A bar inter B bar. Application. Given the following sets E equals A and B. A union B, all the elements in A and B. So 1, 2, 4, 6, 12. A union B. A bar, the elements which are in E and not in A. 2, 4, 12. So we have to delete 2, 4, 12 from E. We still have 1, 3, 6. This is A bar. B bar, we delete 1, 4, 6, 12. 1, 4, 6, 12 from the set E. We still have 3, 2. A bar inter B bar is 3. The number 3. A bar inter B bar is the element 3. A union B bar, A union B is 1, 2, 4, 6, 12. A union B bars, it means the elements of E not belonging to A union B, this is 3, only 3. A union B bar equals 3. What do we conclude? A union B bar equals A bar inter B bar. Set of numbers. Set of natural integers. The set of natural integers is the set of whole numbers 0, 1, 2, 3, 4, 5, etc. For example, 203 is an element in n. The set of natural integers is designated by the capital letter N. So every whole number belongs to N. 100 million belongs to N. 100,075,000 belongs to N. N star is N without 0. So 1, 2, 3, etc. Z, the set of relative integers, is the set containing the positive whole numbers and the negative whole numbers, the relative integers. This is Z. Minus whole numbers, 0, and plus whole numbers. Z star is Z deprived of 0. Z without 0. This is Z star. Every element in N is an element in Z, so N subset Z. N subset Z. All the elements of N are in Z. The set of decimal numbers is the capital letter D contains the plus or minus AB, where A is an integer and B is the decimal part. And B is the decimal part. The number of digits in the decimal part should be finite. We can count the digits in the decimal part. For example, minus 7.32 belongs to D because the decimal part is formed by 2 digits, 3 and 2. Seven over 2 equals 3.5. 7 over 2 equals 3.5. We have 1 digit in the decimal part, so it is a decimal number. 4 over 3, if we divide 4 over 3, we got 1.3333, etc. We cannot count the number of the digits in the decimal part, so this number does not belong to D. 3 equals 3.0. Any integer is a decimal number, can be written as 3.0. Here we have only 1 digit in the decimal part. Then 3 belongs to D. Every integer is a decimal number. So what do we conclude? N subset Z subset D. Set of rational numbers. The rational numbers are in the form of a fraction A over B, where A belongs to Z and B belongs to Z star. Like this. Q, the rational, the set of rational numbers is denoted by capital letter Q. The number minus 7 over 4 fraction belongs to Q. 5 over 2 fraction belongs to Q. 7.128 belongs to Q because 7.128 is 7,128 divided by 1,000. Divided by 1,000. 456.124 is 456,124 divided by 1,000. So all these numbers are in the form of fractions. They are rational numbers. Every integer can be written as A over B, because number 5 equals 5 over 1. 5 over 1 is a fraction. Then all the integers are in Q, are in D, and all the decimal numbers are in D. Any decimal number is a rational number because every decimal number can be written in the form of a fraction, as we have seen. The number 1.333 does not belong to D, but 1.333 equals 4 over 3 belongs to Q. Why this number does not belong to D? Because the number of digits in the decimal part is not finite. 1.33 equals 4 over 3 fraction belongs to Q. We cannot write the number 12.235 etc. in the form of a fraction because here the decimal part is unlimited, not limited, is unlimited and not periodic. So this number is not a rational number. Also the number radical 5, if we calculate radical 5 making use of the calculator, we got the decimal part is formed by an infinite number of digits. Thanks for following and good luck.